Functions. Okay. Ready? 5 question minimum will come. How many questions? 5 questions minimum will come from functions only. Okay? Clear? From where? First, the definition of a function, domain of a function, and range of a function. You may expect separate questions also, but minimum out of these three, one question guaranteed will be there. Okay? Clear? Second, checking the one-oneness of a function or onto-ness of a function. Surjective, injective, bijective. Yes or no? Third, finding the inverse of a function. Fourth, composition of two functions. Clear? And fifth question, increasing or decreasing functions. Okay? Though this is not exactly a part of the chapter function, it is a part of applications of differentiation. Okay? But I count it as a function question. Straightforward 5 to 6 questions will come from the chapter functions. Okay? Clear? Arrow means increasing and decreasing. Increasing function or decreasing function. Fine. Now, before actually getting into the theory of the functions, you must understand three things. Okay? Function is nothing but a machine. Function is what? A machine. Suppose juicer. Okay? Sure. ठीक है, उसको कवर भी कर देते हैं. So juicer is a machine. Clear? Why? Because why is juicer a machine? When I put orange into it and do the grrr, then I am damn sure that what will come out is orange juice. Yes or no? Clear? I am not thinking, today I have put apple into it, let me see what comes out. No. There is no doubtfulness like is coming. There is no doubtfulness like this. Okay? We are very much clear that if we have put beetroot into it, beetroot juice will come out. If we have put Karela, bitter gourd into it, bitter gourd juice will come out. If we have put apple, orange, banana, milk into it, a smoothie will come out. Understood or not? Clear? We are not doubtful that when there is a given input, we know the exact output. Understood or not? Clear? Sure. So what is a function? Function is a mathematical machine where for a given input, there is a fixed and well-defined output. Clear? Sure. Like I'll write a very simple machine. If I say f of x is equals to 2x minus 3. This is a function because when I put x equal to 1, I know that the answer will be minus 1. I am not doubtful here after putting x equal to 1 what will come out. No. We know that a fixed output will come out. Clear or not? Sure. The collection of that input is called domain. Clear? Sure? Fine. Understand this. Can you put stones into this juicer? they will damage this. Hence, fruits and vegetables and milk, honey, sugar, etc. are allowed in it. Stones, rocks, soil, sand is not allowed in it. So there is a certain set of elements which are allowed. There is a certain set of elements which are not allowed. What is allowed is called domain. It's called domain. DOMAIN. Clear? Sure? Fine. As it is juicer, I know I can make juice out of it. I can make pachadi out of it. Right or not? Clear? Right word, no? Pachadi. Sachi. Okay? I can make pachadi out of it. I can make smoothie out of it. Clear? I can make milkshake out of it. So there is a certain set of things which can be expected out of it. So the set of outputs is called codomain. Sure? Fine. So for a given function mathematically, there is a domain, the inputs, and there is a codomain, the possible output. Clear or not? Among all the possible outputs, what exactly comes out, this is called range. This is called, that you must understand. Okay? Clear? So, what is actually coming out is called range. Fine? For example, I will give you a case. Suppose there is a function mod x. There is a function mod x, whose domain is all the real numbers, whose codomain is also all the real numbers. Fine? So I can put any real number inside it. Suppose I put plus 2. What will come out? Plus 2. Yes or no? Sure. Is plus 2 a real number? Okay. Sure. If I will put minus 2, what will come out? Is plus 2 a real number? So can I say that though the domain is real number and the codomain is also real number, but the range is only positive real numbers including 0? Yes or no? Yes or no? So the range do not have to be exactly same as the codomain. Are we clear with this line? Sure. Okay. This must be remembered because statement based questions will come from theory. So you should be clear regarding the theory that what is domain, what all is allowed is domain. What is codomain, what all is probable, that is called codomain. Clear? What is range, what exactly comes out is called range. Sure? Understood? Sure? So now, some standard notes. So you know very well that if the function is a reciprocal function, then the denominator cannot be equal to 0. If the function is a square root function, then x cannot be equal to negative. X should always be, sorry, wrong bracket, 0 to infinity. Are we clear? Yes or no? Understood this? Sure? Beyond these two, understand, there are three standard functions. They are the mod x, the greatest integral function of x, and signum x. Sure? For mod x, the domain is all real number, the range is only 0 to infinity. Clear or not? Sure? Okay. Very, very favorite of UPSC. If in your paper you have not seen greatest integral function question, then one thing is you have not read the full paper. And second thing is you have not got the NDA paper only, some else other paper only have been given to you. Clear? So, if from question number 1 to 120 of mathematics you have studied and you do not find the greatest integral function, GIF, clear, then it means that you have not got the NDA paper. It is some other paper only you are writing. Clear? It is that important. Fine. Now, what is the meaning of greatest integral function? Understand. If I put a number 2.01, its output will be 2. So the definition of greatest integral function is, for any real number, the output is closest lesser integer. Closest lesser integer. For example, if you can imagine the number line, can you imagine the number line? -5, -3, -4, -2, -1, 0, 1, somewhere 10 is written. Okay? Clear? Sure. So if I give 7.99, then what will be the answer? 8 or 7? So the answer will be 7. Why? Because, clear? Sure. Understood? Ready? Suppose I give a number -5.11. What is the answer? -6, -5. -6. Why? Lesser. -5. If I cross this, then my landing will be here. Understood or not? Clear? Lesser number. Okay? Sure? Remember this. This is important. Clear? So we can generalize this. I invest some time here because this is very, very important. This question is going to be there. Greatest integral function is going to be there in your paper. ध्यान से. If input is equals to a positive real number, okay, of the form n point decimal, then the answer is n. Understood or not? Clear? Sure. If the input is a negative real number of the format negative n point decimal, then the answer is negative n plus 1. Please. Sure? One more time. Very. You understood this line? No? Good. See, if the input is 2.5, if the input is positive, so the answer will be 2. But the input is negative 2.5, then the answer will be negative 2 plus 1, negative 3. Clear? Sure? Understood? Everyone? Clear? Now, noted everyone? Sure. Now going into the actual crux of the chapter from where straight questions will come. For this part, I will not take domain and range. Domain and range is a complex area. Maths can disturb you over there. What I said? Domain and range is a complex area. Maths can disturb you over there. What are we talking about? We are talking. ये लाइट जल रहा है ना? हाँ. What are we talking about? We are talking about the 4 question where maths is not required. If you understand the method, you will be able to clear the scenario. Sure? Understood? So first case is checking whether a given function is 1, 1 or not. Okay? So, if they give you a function f of x equal to 2x plus 1 and ask you check whether this is 1 1 or not, it's very very easy. Look here, you have to just write 2x1 plus 1 equal to 2x2 plus 1 and simplify. If you get x1 equal to x2, then this function is 1 1, else it is not. For example, if the same question would have been 2x square minus 1, then you would be like 2x1 square minus 1 equal to 2x2 square minus 1. 1 and 1 got, 2 and 2 got, x1 square is equals to x2 square implies x1 equal to plus or minus x2. Clear? Here x1 is not coming exactly equal to x2. So this is not a 1 1 function. Clear? For a 1 1 function, by taking this step, the final answer should come as x1 equal to x2. Try on this function. If a function is given by this, check whether this is 1 1 or not. Check. If a function is given by this, check whether it is 1 1 or not. Do it. Do it. Okay. What you should have done? x1 minus 1 upon 2 minus 3x1 equal to x2 minus 1 upon 2 minus 3x2. Here, this goes here, this goes here. 2x1 minus 3x1 x2. Yes or no? Clear? Minus 2 plus 3x2 equal to 2x2 minus 2 minus 3x1 x2 plus 3x1. Yes or no? You can see very well 3 got cancelled, negative 2 got cancelled. Clear? So if you send this 2x2 this side, you get x2. If you send this 2x1 that side, you get x1. Are they coming directly equal? Clear? So this function is 1 1. Okay? This is not mathematics. You don't have to think about too many concepts. Pure algorithm. If you follow that and you land, you will say, "Haan bhai, my question is done." Clear? Sure. Next question is checking the onto-ness of a function. So the meaning of onto is that domain and codomain are there. No element of the codomain should be left unattended. What is the meaning of onto function? No need to write it. That all the elements of the codomain have to get a pre-image. Okay, they should be an answer of an equation. Clear? Implies that when codomain is equal to the range of a function, that function is called onto function. That function is called onto function. A function whose complete set of possible answers are actually coming as answers is called a onto function. Clear? Look here. The method is very easy. If a function is given, then you have to invert it as x equal to equations of y. It is y equal to equation of x. It is what? Y equal to equation of x. Your responsibility is to convert it to x equal to equation of y. So from here, y minus 1 by 2 equal to x. Yes or no? Clear? If you are able to do this, it is an onto function. Else it is not an onto function. Clear? Sure. For example, let me take a complex one. Suppose you would have said 2x minus 1 upon x plus 2. This is equal to y. Now what I am doing, I will send it here. I will get 2x minus y equal to xy plus 2y. Gather all the x's at one side and non-x's at one side. So it is 2y plus 1. Here x common 2 minus y. Yes or no? If this goes here, yes, I am getting an expression x equal to 2y plus 1 upon 2 minus y. Yes, this is making the function on 2. Clear? Sure. Also good news. This is also the inverse of the function. This is also the... So, by giving this function, if they ask you find f inverse x, then do the same thing. Just write the final answer in the form of x. 2x plus 1 upon 2 minus x. Though for this question, actually in the exam, you have an option method also. We'll discuss about it. Okay? Clear? But still, fine. For checking the onto-ness, for finding the range and for finding the inverse, this is the same thing. You have to do this step from here for 3 things. To find the range, this is required. To find the inverse, it is required. Clear? And to check the onto-ness of the function, it is required. This single step conversion will help you out in how many questions? 3. To find the range, it is required. Okay. To find the inverse, it is required. Clear? And to check whether the given function is onto or not, it is required. Clear? Understood? Sure? Very good. Proceed. So, if we list our targets, then you know this? Yes or no? And you know this. Here, I am coming to this now. Ready? If I ask you that there is a function 2x minus 3, and ask you what is the value of f of 1. So what is the answer? What is the value f of minus 1? What is the answer? What is the value of minus 5? What is the answer? So instead of asking all the three steps separately, what I ask is, what is f of x? Which can also be written f of x. So your answer is very easy. Sir, suppose you have asked sir, f of 3. Suppose I have asked you what? F of 3. So your answer is, sir, what is f of 3? Sir, what is f of 3? And what is f of 3? So our final answer is understood, clear, sure. Suppose I ask the same question. F of 5, what is the answer? So you will say, sir, what is f of 5? 7. So sir, what is f of 7? So final answer is clear, sure, clear. This is called composition of function. This is called what? Sure, clear. Now there it is not mandatory that you will get same function. You may get different functions also. You may get, note down. Suppose f of x is 3x minus 2 and g of x is 3 minus 2x. So you have to give me what is the value of fg of 1 and gf of 1. I am doing this. So you will say, sir, f of 1 means sir, g of 1. Clear or not? Right, here also, if I say g of 1 and f of 1, understood? It does not mean that always they are same. Only in this case they are same. Clear? Sure? Understood? Sure? Now, find the expression of if f of x is x minus 2 upon 1 minus 2x and g of x is 2x plus 1 upon 2 minus x. Then find f of g of 1. Quick. So sir, g of 1 is, answer f of 3 is, clear? Sure. Please find gfg of 1. No, wrong. fgf of 1. Chalo. So this is how much? Minus 1 by minus 1. Yes or no? Yes or no? Means this is coming as 1. Now g of 1 is, answer f of 3 is, clear? Sure? Understood? Understood the composition? Clear? Okay? But now I am looking for the mathematical expression. Give me the mathematical expression of g of f of x. Chalo, start. So you will say, sir, g of, what is f of x? Clear? So sir, wherever in the g x is written, we have to write this whole. Okay, ready? So 2 into x minus 2 upon 1 minus 2x plus 1 upon 2 minus x minus 2 upon 1 minus. Clear? LCM in the numerator is 1 minus 2x visible? Yes or no? So 2x minus 4 plus 1 minus 2x. Yes or no? So numerator is coming minus 3 by 1 minus 2x. This is the numerator. Look at the denominator. Denominator LCM is 1 minus 2x. 2 minus 4x minus x plus 2. Yes or no? Sure. So denominator is coming what? 4 minus 5x whole by 1 minus 2x. 1 minus 2x, 1 minus 2x got cancelled. So the expression is coming as minus 3 by 4 minus 5x. Or you can put the minus down and it can come 3 by 5x minus 4. Clear? Sure. But I am suggesting you one thing. Mostly this question in the exam will be done easily with the help of options. So don't worry, but still you know the algebraic solution. Clear? Sure? Clear? So 1 1 on 2, clear. Inverse, clear. Composition, clear. Okay? Now coming straight to increasing and decreasing. And it is very, very easy. If a function is defined, then if the differentiation of the function is greater than 0, it is called increasing. If the differentiation of function is less than 0, it is called decreasing. Here, at time they can play with you on the word strictly increasing or strictly decreasing. Because in normal increasing or decreasing, 0 is also included. But in strictly increasing or decreasing, 0 is not included. Just note this. So 1 1 on 2, inverse, yes or no? Clear? 1 1 on 2, inverse, composition and increasing and decreasing. Clear? So minimum 4 questions will be there in the paper which you can tackle anyway. Okay?